Everybody, I am Kevin Totterell of RMUS Canada, and it is great to be back here hosting another webinar. It's been a little while since we've done one of these. We've been doing a lot on the podcast, Did You Bring the Batteries, where we hope to have all these three gentlemen in the new year to talk about what we're going to discuss today in depth. So make sure you check that out. And how to start it, I guess, if we think about the drone industry, we've been talking about really BV loss for forever, right? Oh, BV loss is going to change the world. It's going to save everything. It's coming. It's going to happen. And for those of us that have been hearing it for 6 years, even though it's getting close, I mean, we've been hearing about it forever, right? But to me, it's exciting, but it's not nearly exciting as what we're starting to see on the autonomy side from some of the drone in a box technologies. And so that's what we want to really focus on today. And although certainly you can do BV loss autonomously, it's certainly not synonymous. And in fact, there are many things that will be not BV loss, which to me just makes this particularly more exciting as well. So we will go ahead here and quickly introduce our panelists. So really what we wanted to look at was different perspectives from hardware and software. So let me first pass along to Josh Ogden from AVSS to do a quick intro of yourself and your company.
Yeah, for sure. Thanks a lot, Kevin, for having me today. My name is Josh Ogden, CEO of AVSS. So AVSS is a Canadian company with offices in New Brunswick, Ontario, as well as a new office in Syracuse, upstate New York. We work primarily on drone safety systems, primarily parachute recovery systems, ASTM F33322 compliant systems, used basically for compliance over people. Some use it for, some of our customers are using it for compliance for beyond visual line of sight, such as in Canada to receive an SFOC. We also work on some guided parachute systems, and we are integrated in a few drone in the box solutions, helping those integrate the autonomy into their workflows.
Great, thanks, Josh. And I think it's a really exciting technology because it's one of those things. And you and I have been talking about this forever. And as you know, I've never been particularly excited about drone parachutes. But you've got me excited, and certainly now we see why you are way ahead of me for sure, and probably a lot of others, and how important this is going to be going forward as we talk about what we're enabling them. So thanks for joining us today, Josh. Secondly, I want to go to Edwin Sanchez. Why don't you go ahead and give us an introduction?
Thank you, Kevin, for having me here. I'm actually glad to share the panel with Josh and Curt. I mean, great technologies, what they have. Votix is actually an American robotics company that is focused on enterprise software for orchestration and automation of drones at industrial levels. We are drone agnostic, sensor agnostic, even application or use agnostic. So think of Votix as a horizontal solution that can support any process for any drone. And we strongly believe that the one size fits all is not the reality in the drone industry. Actually, companies will end up using different drones, different sensors, different stations, different workflows. And we are here just to provide a solution that can orchestrate all of that ecosystem and make it effective and service well for corporations. That's what Votix does. In particular, I am the company's CTO and founder. We launched Votix this year, even though we have been building the technology for the last 4 years. We just really wanted to make sure that the technology was fantastic, thousands and thousands of testing hours and missions, and we're very proud of it. Right now the customers and all the different companies and partners who had an opportunity to test the technology and even use it for industrial capacities are impressed and happy to leverage on our technology.
Fantastic. And again, I remember seeing your booth at CUAV and saying, wow, it's a great looking booth. I wonder what they do. and AVSI as well, and it was great to learn, and again, very exciting product, and what it enables is spot on today. So I'm glad you were able to join us.
Thank you, Kevin, and looking forward to this discussion anyways.
Yeah, and last but not least, Curt, Lary from Hextronics, and Curt, go ahead and give us an intro, please.
Thank you, Kevin. Really excited to be here today with this panel. And so I'm the CEO, founder, and pretty much engineer of Hextronics. At Hextronics, we design and manufacture the drone in a box, or the box, essentially, the nest, the home, the station, the hangar, whatever anyone's calling it, that's us. And we are essentially focusing on that critical component and integrating with many of the industry's best off-the-shelf and other drones that are available, in order to make a relatively drone-agnostic approach to the industry, where we believe everyone's focusing on their key role in BVLOS, and our key role is the station. We're operational in over 20 countries, 6 of the 7 continents. Antarctica, we're coming for you. You're on our roadmap. And we are with some of the world's leading drones. So we've got our initial system shipped across the world, for the Mavic 2. That was our first product. Now the Atlas for the M300 as well, and then a new system that we're really excited to talk about as well, which is the Universal that's coming out, that will be able to service many of the drones and the DJI, Parrot, the Skydio, Autel, and many other different drone stacks all in one system. And we're very excited to play this role, very excited to work with many of the other key players in the industry, and excited to talk more about it today. Thank you, Kevin.
Excellent. Well, I mean, you can see now we've assembled really an all-star panel. A couple of things jump out right away to me is drone agnostic. So all 3 of these individuals are drone agnostic, number one, and number two, I think a friend of ours, and probably many of you watching, Bobby Sakaki, who talks a little bit about, more collaborations required and is necessary. You don't have to try and build everything yourselves. And I think that's important, because the way forward is going to be to use different types of things. And so that's really important. And I think all of you are really showing you're part of that. So first thing, before we get into the most important question, I just want to give a quick shout out. It's very apropos. So people are saying, oh, drone in the box technology, we've seen it at shows, Well, I can tell you that I believe the first official deployment, shout out to the team over at Ontario Power Generation, OPG. They received last week the first, I believe, BVLOS waiver in Canada for a drone in the box system that is now in operation. So this is real, people. So shout out to Tim and Vajira and the whole team over there for their great work, and we're excited to continue to partner with them. So anyways, with that out of the way, let's get into this. So first thing is we probably should talk about what do we actually mean by autonomy? Is that like different than autonomous? Like what is it? What does this all mean when we say that? So Josh, I'm going to throw it over to you to kick it off, and then the others can kind of jump in. So what do we actually mean by autonomy?
Yeah, I think today where we're at in the market, there's certain regulatory constraints on going full autonomous, going out and making all these autonomous decisions without human in the loop kind of input. I think what we see a lot of right now is a lot of waypoint flights and, predetermined locations that we need to go with. If we think of a drone or box solution at like a refinery or something where they're doing, some asset inspections or security, a constant security kind of map on a weekly, daily basis type thing. I think that's where the waypoints come in. And I think where we're at with the autonomy is we have to recognize there's still a lot of edge cases that haven't been addressed. And the good first step is to realize when you're implementing these solutions that you don't want a complete, level 5, I guess, in the automotive world, autonomous solution. You want a waypoint system that's going to go out and, one, to prove out your case, get your business data, as well as to get the regulator approval. And I think I think there's some solutions out there that we're gonna have full autonomous solutions that go out and are very intelligent. They're doing a lot of sensitive void. They're avoiding and they're making decisions. But I think at where we're at today in the industry, it's just there's still a little ways to go. It's always a couple years away, but it's almost there.
Excellent. So Edwin, what are your thoughts on some of this? What does this all mean actually?
Yeah, well, that's a great question here. First of all, autonomy means, I may say, a different thing in the drone industry right now than what it means to other industries, like, for example, the autonomous cars or some other type of autonomy through robots. And we're more in what we may call automation better, so let me just clarify that. Autonomous is more about, AI making, decisions without human intervention in most of the cases. While autonomy, it's more about, or automation is more about, conducting a number of different steps that are pre-planned, and certain decisions are made in the process, but very minimal. And I think we are in the automation part. We're going towards autonomy, but I don't think we are there yet. There's plenty of things that need to happen before we can say that we're really running autonomous operations with drones right now, at least in an industrial private context or even governmental. Um, so I would like to focus it that way because most of the things that we can talk about here, it's the use of AI in certain pre-planned processes as an autonomous operation, um, but not really, drones making their own decisions without human intervention, which is, high end yet and still in pure development.
Right. Very, very Terminator, Rise of the Machines kind of stuff.
Yeah, exactly. Not happening yet, at least not in the overall industrial context.
So Curt, you have a little different take on it, or not take, but maybe perspective. So tell me what your thoughts are from your side.
Yeah, so it's kind of to Josh's point, waypoint following is essentially the foundation to what we're really excited about, which is the end result. Like, okay, great, you have a automatic drone that can fly around, do circles around a tree, go and make its own flight path, and really just do things without human input, all on the fly, all in autonomy. And it's relatively high risk, it's complex, it's high compute intensive, and it's just not really easy to get a blanket approval for. It's like, hey, can I get an approval? My drone's going to go around and do whatever the heck it wants. That's okay, right, FAA? They're going to be like,
no,
let's just stick to a defined route. Let's figure out how to capture as much data as we can. And if the route's got to be, 10 different flights that are all like on a grid that just make a good 3D map, that's really what you need to then take it to the next level of being able to conduct the analysis and the reporting and the data extraction that's necessary. And so while, yeah, we could go forever into making the drone fly around and pretty things on its own, let's just use it to gain the value that we need to make critical decisions. And in doing this, making a good foundation for drone autonomy, where autonomy is just following a path in order to get to extract this data, then we can enable a wide variety of players and solution providers to then add their level of key data interaction on a foundation that is very well defined, very easy to get approved, and very scalable in operations. And so my take on autonomy is, let's focus on what we know. Let's bulletproof that. Hextronics drone systems are already deployed across the world with more than 50,000 cycles doing exactly this, just following waypoint missions and coming back home. Let's just take that to the moon and start enhancing the data extraction that we can do upon it.
Perfect. I think it's fantastic points, because I know, we've been doing this on the ground with Spot for quite a while, and that's That's what it is. Can I get it? Can I get it, my sensor someplace? Can I do something when I'm there? And can I just let it go without me having to pay attention to it, right? And so, we don't have to do this fancy. I can tell you, as all you guys can, that there are incredible use cases and incredible ROI and value for just doing that. And we shouldn't even say just, because being able to do that is huge. So let's focus on, now that we've kind of clarified, what it is and where it is. Let's talk about how we get to, actually putting this in use, because I think when people hear those kind of words, they get nervous, and the first thing they think is, oh my gosh, we got like this crazy regulatory environment, FAA, Transport Canada, whatever in Europe, all these things that it's going to make it really tough. And so you guys have actually kind of a unique position, because you're working extensively with regulators of all sorts to deal with their issues, and you all have unique issues for all three of you. So, so Josh, I'm going to throw it back to you. So from a regulatory perspective, what are some of the things that, when you're going to launch one of these programs, that you're going to have to do to satisfy the regulator?
Yeah, for sure. And I think before you even launch a program, I think one thing, having that business case and validating, it makes sense. Either you're really replacing, like if we think of a drone in a box solution that has some autonomous capabilities, I think you're replacing a pilot that's going and doing a repetitive task, whether that's a pilot on the top of a police station, or pilots who have to go to these remote regions to do, monthly inspections of the same asset that's not moving. And so once you, confirm that business case and know the use case, I think the next step is looking at the regulations and understanding what are some potential impacts that you're going to have. Because again, if you're not aligning with the regulations, so if you want to do, in the port over people, you're going to need the safety systems. You're going to do some risk assessments, depending if you're in the States versus Canada versus Europe. If you're in the FAA, if you're waiting for the FAA for some of these solutions, you might be waiting a little bit longer than in some other countries that are a bit more pro drones flying in more complex environments. And so I think for the regulators, you got to build up that safety case, and you got to get that data. So like, we've seen a customer with the drone in the box solution, spend a year doing proof of concepts, validating, demonstrating, and they knew that this was a cost of doing business for the first set. And then after that year, they start looking at how do they scale out to multiple locations. And that's where they're, getting through the safety case. Because I think you don't want to have a false start. You don't want to go build out a business case, go implement it, and then try to rush to scale. You go from 1 to 10. And then when you get to 10, you stumble because of the safety and the regulator coming in and grounding your operations. So if you want to smooth operations, you want to think of what are the requirements. So if you're using flight over people in Canada, if you're having to do a PDRA or just the standard SORA for in Europe, I think you have to look at what are those regulatory constraints, and maybe not shoot for everything at once. I think with regulations, sometimes people want to go to that full, complete solution right off the bat. And really it's like, okay, it is the crawl, walk, run approach. I think we're beyond the crawl at this point in the industry, but like, we don't want to walk too fast. We don't want to go out in the full sprint yet. So there's that balance that you have to kind of make. And I think the biggest thing is don't force it. I think a lot of people in the industry come from backgrounds that, if you're a service provider, you used to, go get your shots, go get your data. But when you're starting to implement these full autonomous solutions, we've got to be careful that we're not forcing it like we would certain types of practices in other industries. And at the end of the day, we're in civil aviation, and safety is a must.
Yeah, makes sense. Excellent, thanks. So Edwin, on that same thing, so Josh talked a lot about risk and documenting risk and, showing that you do this. So talk about that. Obviously, totally different from the hardware perspective. So from the software side, how does Votix and what you do really enable regulators to get a warm fuzzy, or at least as warm and fuzzy as they can get with this?
Yeah, well, first of all, regulators, they really want to create relationships with the industry and different operators to ensure that things are done the right way. And more regulators are interested in seeing software technology involved in the process, along with obviously safety management or risk reduction technologies like Josh's and Curt. Now, What's important here is that that's not the only area of risk or concern for an operation to be successful, even for regulators to feel comfortable. There's actually industry-specific regulations, that are not, statewide or countrywide, that need to be factored in, or let's say job-specific regulations or rules that are also important. And any of these fail, or you don't count for this in your workflow, and you run into a problem, and chances are the regulators will be spooked, and they'll feel like you're not planning accordingly, or you're not actually having every moving part into consideration. So you got to be careful that you got to orchestrate, and you got to have a holistic control on every moving part in the process. That involves what's going to happen with the aircraft if something happens, what are the different types of fail safe that you have? How do you anticipate a problem if you can? What are the rules of management or risks management in case an event occurs? How do you document that if we come back to you? How do you manage in real time a situation trying to reduce, the impact of a potential problem? And in most of the cases, what is it that you can automate? Because when you can automate, you can in advance test and reduce all the potential human errors or risks associated with human intervention, and put it in terms of an automated solution. Ultimately, I strongly believe that the automation won't remove pilots from the math. It will enhance the capacity of pilots and other operators in the workflow. And that's actually the direction. Last comment on this, Kevin, if you think the pace at which drones are coming to the market and being sold and used in industrial contexts, there's not enough pilots in the world to attend all of those aircraft or all of those drones that are going to be available. So to some extent, a pilot or a service provider will need to rely on a certain level of automation to be able to deliver a complete solution or all the services that they can do.
I think that's great insight, Edwin. Thank you very much. So Curt, so we talked about it from a regulatory perspective, and I think this is a nice segue for safe operations in general as well. So maybe talk about some of the things you're doing to enable safe operations from an operational perspective, and obviously to satisfy the regulations with pre-flight and all kinds of those features that are built in that can really help ensure smooth flowing there.
Yeah, sure, Kevin. So as Hextronics is also the manufacturer, it's kind of double-sided, where in order to ensure for smooth operation, we make sure that every station or nest is manufactured to the same level and is all documented. So we're actually having to follow some similar process requirements as aircraft would when it comes to ensuring that every single or a wide variety of systems deployed are well documented and conform to a specific standard. And then when it comes to operation, as we've got experience in a wide variety of countries, each regulator has kind of different types of approvals and checklists that need to be attended to. Some are more lenient than others. A lot of it goes into visual and electrical and mechanical inspection and analysis of the aircraft before flight. And so many of our systems do have the capability of integrating with something as simple as like a USB or an IP camera in order to perform, in some cases, visual inspection of the drone's propellers, of the drone's battery, and of the drone's overall airframe, ensuring that all is up to spec and is clear for takeoff. And then also when it comes to the visual feed of the drone when landing, precision landing is probably one of the most critical aspects of this entire drone in a box space. And you've got to make sure you can come back to home, because that's where there's that's something that's going to be done in a wide variety of environments, wind conditions, and use cases. And if you can confirm that you've landed back at base, then it really goes it goes pretty far when it comes to regulatory approval as well as confirmation of landing. And we, in some senses, do this from the feed of the drone, ensuring that the drone is in the appropriate position when returning into the station, or just from a camera feed live from the nest. And so cameras do play a critical role, not just on the drone, but also within and viewing at the station. And that's a good way to perform these checks. Some are becoming to be more and more automatic, where they've got vision analysis of each of these critical components being done.
Perfect. So Josh, obviously you probably have like an even more direct thing, don't have the drone fall on anyone or anything. So maybe talk a little bit about your part of it, and then just as a secondary part, how you would work with hardware partners to ensure compliance and safety on the full solution.
Yeah, so luckily for our vertical segment of the drone industry, there are some standards already created, published, and accepted. The ASTM F3322, which is the parachute recovery system standard, was first published in 2018 and has been accepted by Transport Canada, by the FAA, and now EASA has a specific standard where MOC 2511, and it's used in your SORA for your risk assessment, M2 mitigation, for those familiar with it. When we look at the parachute standard and where it's come and what it needs to do, it's a very interesting add-on, I guess. A lot of people think parachutes are simple, just slap it on and it goes. And anyone who's worked with parachutes knows, I think it's a little bit more complex than that. And I think the big thing too is just the collaboration. The industry is at a weird spot where people have been working, I don't think it's COVID, but maybe we'll blame COVID in isolation a bit, and that they're not collaborating necessarily for the full stack system. And I think when we look at where the drone market's at and we look at the integration, there's different elements, and it's a pretty dynamic environment. So when you're integrating a system, like, we have to go through quite a few checks on, like, what countries are you focusing on? Are you looking at, for example, in Europe, something called enhanced containment, which has a different requirement for one of the features of the product called a flight termination system, which ultimately stops the propellers from spinning. But how you do it, there's some different methodologies. And I think where the regulation's at and where we fit and what we're seeing is, as the more companies collaborate, there's a lot of shared learnings. And there's things that, like, again, talking, if we look at Curt's system and talking about cameras, like visual inspections, it's a very important item that might be overlooked. And, if you're not collaborating appropriately with your partners, you might add a feature and not know that it doesn't work. It's in conflict. And then, you want, all companies kind of, no one wants to do any changes, and the client doesn't want to pay for anything. But ultimately, it comes down to, there's so many new elements, and it's such a dynamic environment that, like, having the companies work together and collaborate. I think what we see for the regulations and approvals, and what we see with the partners today, it is that walk. But we're going to run very quickly once those collaborations get stronger, and there's lessons learned passed on year over year on the new iterations of the product. And I think, I'm sure, Curt, when you first started your Drone in the Box, did you think that you would have to have cameras doing visual inspections as your first feature set? Like, I'm sure there's things that have come out and you're like, oh, it makes sense. Sure. It's kind of like, let's not have drones fall out of the sky. That kind of makes sense. But, like, we don't always get there right away.
Yeah, makes sense.
I agree with Josh completely.
Yeah. So Edwin, in terms of some of the safe operations, talk about some of the features in the software. It could be anything as simple as like geofencing to some of the other ones that are going to enable, whether it's an asset owner just worried about dropping it onto expensive equipment, or a drone as a first responder that Josh alluded to, which is really more concerned with people. So talk about some of the.
There's plenty, actually. So the first thing is that we, as a software company and as a software priority, it's safety in terms of ensuring the safety of the operation and the safety of the equipment that is being used. So in that aspect, we embrace and rely on whatever safety features are on board the drone. So we don't disable anything related to the drone's safety features. Let's say there's a parachute, there's collision avoidance that is built in the drone. We definitely use and rely on those. Even though we have ways to have the end user disabling or enabling those things on the drone, in general, automatically or by default, we don't disable any of those features. However, from a software standpoint, there's plenty of things. Let's say the very first part of the workflow, before even flying, planning is very important. So we provide substantial tools for planning, creating, as you say, geofence 3D geofences that are extremely important to operate. Just to give you an example, we had the chance to work with an international government in a project that was called the highway over a river. I cannot mention the details of a project simply because it was asked to remain a little bit, confidential. But I can say it was actually a highway on a 25 kilometers highway over the river, drone highway in two directions. So they used our technology to create two different geofences, one below the other, and they had drones going in one direction over one and below, in the other direction, which is great, and it provides, a safe way of avoiding conflicts in between drones. But even better, they had aircraft flying above, that area, and they were able to prove the authorities, the aeronautical authorities, that this was perfectly safe, and drones won't run over any potential problem for the manned aircraft. Now, when you have that planning and having, thorough planning, it's important, and being able to reuse those plans, by different pilots or users is also important. So that reduces significantly, the potential incidence of an error in the process. Now, once you go through that and having the software verifying that those things match, or those things, check in, like, creating a mission under certain actions and certain conditions that do not violate certain regulations, or that you don't fly your drone under certain height or above certain height, and having all of that verified by the software and saying, oh, we're all good for that, it's great. And then moving on to the effective operation itself. Real time is important. So we have extremely low latency for any drone, actually. Let me give you an example. We're in collaboration with Curt, we're partners, and we are the first ones to support Curt's station for Parrot, with a Parrot aircraft that is fully autonomous, and does not rely on a remote controller, is directly connected to a station through our technology, and with a latency that is even lower than an AVSS itself or Parrot itself. It's actually less than a quarter of a second. That way, that environment creates a really potent capacity to react in real time to any situation that may arise in this. And we can also connect other feeds. Curt was mentioning, other cameras that are around the station or inside the station. We can combine all of that to provide a better situational awareness that can be used in different contexts. So that's also important. Now, lastly, we support, or not lastly, actually, in that real-time operation, if something happens, there's a number of different things that the software can do on top of the safety features that are on board the drone or that are inside the drone, that we can leverage on, like landing on safety points, or what we call rally points, that are not the home point, but are immediate nearby. So our software can calculate where is the nearest safe point to land. We can actually do what's loss of signal, GPS, for example, GPS denial situation, and manage those things. So there's plenty, and obviously we support precision landing, and you can have precision landing in different places. So you can precision land, not even in the home. Let's say the drone has to land in a precise place, but it's not the station or the place where it took off. So we can land, precision land in those places, or even a mobile, object like a van or a car. And lastly, analytics. So not actually precision analytics from the data capture, but better program and performance, drone performance analytics. That's extremely important to reacting or solving problems that may arise throughout a mission, to replicate or correct for future operations. So that's kind of the things we have implemented in the software.
Fantastic, yeah, and it's important, and I know, there's obviously it's important for asset owners, but as we see like DFR responses, they need to be able to show the public, hey, here's where we flew this, here's what happened, here's all these, here's all this stuff, and so the public feels comfortable that we're not being spied on. Right?
Yeah, well, with telecontrolling, it's good that you mentioned the DFR because we have been very active in the DFR industry right now, or DFR needs from different governments, because we allow for remote control, telecontrol, real time with low latency, and all of these features involved. So 911, operators can launch the drone, bring it to a place, and then start capturing data there. A police officer can man, one or several drones from his car or her car, and perform a number of different things, or have a station nearby in an area, that is, let's say, zoned somehow, and being able to surveil a certain zone and provide aerial support to that area using our software. That's extremely powerful for enhancing the capability of a DFR implementation.
Perfect.
Yeah, and I think one thing to chime in on that, Kevin, but your comment again, I think sometimes us in the industry we might lose sight into, we have all these features, but I think the social acceptance piece. I know that Transport Canada has a specific group looking at the social acceptance, and I know in the States the discussion around remote ID, Big Brother, people giving my location, and the fear kind of some of the elements of drone might have a different perspective. But I know, again, going back to drone as first responder, that's where I think Chula Vista's done such a great job, and that they actually publicly disclose every single flight. And I know there's some countries and some different cultures that maybe they don't think that's necessary. The police do not have that role, and they don't need to disclose what they're doing. But I think when we're looking at drone as a first responder, and North America, European countries, New Zealand, Australia, kind of the countries where some of that information sharing is vital, and that the public disclosure of flight logs is like, anytime I've shown someone a drone as a first responder and we start going down and, there's the fear, oh, frig, there's a drone over my head there, what are they watching? It's just not a peeping Tom. It's, Big Brother. But that disclosure of flights on a regular basis, and like, I'm pretty sure you go to Chula Vista's website today, it's updated as of yesterday. And so like that transparency, I think, is something that the drone industry lacks in our own practices with regulations on standards and testing results. And you never know what the truth is. And I think at the same time as these police departments look at drone as first responder, it's going to be very powerful, but we need to make sure that there's public disclosure, and you're not hiding information that should be out there. And I think just the general concept of going out and doing your public engagement, I think that's where the drone delivery companies like Google Wing, Mana have gone out and discussed with their communities. It's one of those ones. We're going to put autonomous robots in the sky, but let's get people involved. And once people understand and can see it, it becomes something of easier to scale in the long run.
Yeah, I love that, Josh. Actually, that's why our software makes a lot of sense, because you have governance. You actually keep track of everything that is happening everywhere in a single place. And that's where communities and government can engage in, hey, what can I see from those missions that are being performed? That is what if they need to audit whatever happened, they can see that. So it's interesting, what you're mentioning, Josh. I totally agree with you.
Yeah. Thanks, Josh. So, Curt, I'm gonna throw it to you now. So let's talk a little bit more about the implementation concerns. We've got a little pathway in place to address safety and regulatory. Now we got to choose the hardware of what we're going to do. And you all kind of mentioned it, but you especially, Curt. Initially, you talked about universality and agnostic and all of those things. So tell me why you think it's important to keep it open and be universal in terms of the hardware that you can use.
Sure, and thank you, Kevin. So basically, we've had systems deployed across the world for just about 2 years now, and we've been fielding quite a wide variety of different inputs from a large amount of customers and users. And we definitely like that feedback has helped us tremendously in the development of the universal product that we've got coming. And one of the main issues is, as we've been discussing, is just the speed of growth of this industry. and the investment that goes into scaling out a wide network of drone systems. And so the drones we're flying today, likely in 5 years, they'll have better cameras, better sensors, more compact, longer battery life, all of this. And so if you commit today to an infrastructure that's set in specific for an individual drone, that's going to be difficult to grow as the industry grows. It's much more difficult to commit to that level of infrastructure. Whereas developing an infrastructure that can grow with the industry, that is drone agnostic, that is capable to work with a wide variety of hardware providers, software providers, different solutions, different add-ons, extra capabilities, where one system can grow over time. That's pretty much where we're focusing on really conquering this layer in the industry of one nest that can really check a wide variety of boxes for different regulatory providers, different industry use cases, and just a wide variety of mission requirements. And so the key point of universality is not building a system that's going to be amazing for today, but a system that's going to be able to grow with the industry over the next 5 years, so you can commit a wide infrastructure kind of rollouts. If you're going to go with a system that's in all of your facilities across the world, say in 50 to 100 different facilities, you want to make sure that you're not going to have to buy a whole bunch of new systems in 2 years when the next one comes out. You're going to want to be able to stick with that system for 10 years and be able to grow it and roll out a wide variety of features for different sectors over the next course of the future.
Retrain everyone, right, Curt? Retrain everyone on a new lineup.
Well, and I think too, this is an interesting topic on a bigger picture that we're going to see, in my opinion, in the drone industry. Is we're starting to see it right now, where there's certain drones that they're in market for 3 or 4 years. Certain organizations are ramping up, spending a bunch of money on these platforms, and then suddenly they become end of life. I know I've seen some companies end of life products 6 months out, and I think we're going to start seeing some legislation. I don't know which country is going to step up first, but where you have certain organizations that can't get certain batteries, where they've spent $100,000 on a LiDAR, they've spent a bunch of money on the platform, training it, they've got all they got spare parts, but then eventually the battery availability removes, and I think we'll see legislation come into place for the right to repair as well, similar to what we see with iPhones. And I think this comes back to the comment about the life cycle of the platform, and the drone industry's got a long ways to go for us to be feeling safe with the system. I think we're going to start seeing the hardware get frozen no longer, and that you'll see firmware updates, that Tesla approach of updating. And there's probably going to be some fees eventually. Someone's got to pay for it. It's got to be sustainable. But I think that right to repair and having those platforms, and that the innovation cycles are still going to be there, but it's going to be more software, firmware driven than the hardware components itself. And so you're not going to get stuck buying a drone in the box. That's 3 years later, the drone's not even available. So I'm sure, Curt, you're in a situation where maybe the Mavic 2 batteries get end of life in 2 years, and suddenly you have customers with those boxes that have to address that issue. And I think that's where the industry, again, there's a lot of things that we need to get better at, but there's certain ones where we have to start protecting the customer, and if not, someone's going to regulate us, right? And I think that's where us taking that longer term view of certain products, and your iterations, from the batteries or any consumable parts are available, and it's a part of making sure that the customers who adopt this technology don't get burnt, right?
Yeah. Actually, without going far on this, and a very, very basic example is we have a customer was using DJI M300 for certain V-loss operations. With us, they got approved for V-loss operations. And of course, the distances they wanted to operate to were impossible to achieve with that DJI drone. So they swapped to a MapLink-based drone hybrid that can run for 5 hours. And that's a totally different platform. So they were able to jump from one drone to the other using our platform, without any hassle. They didn't have to change, the planning, all the missioning, all the geofencing, everything was the same, just the aircraft changed. Um, um, when doing it in a different way will have meant, for them to do or rebuild everything from scratch. So that's the kind of things that are important here too. And again, to Josh's point, customers for one reason or another, and companies out there in the market will have eventually to change their equipment. It's not a matter of if, it's a matter of when. And they have to think in advance about what's going to happen with the rest of the process, not only the aircraft. My whole, workflow, how's that going to be impacted when I change even a single battery, a single drone, is going to create a nightmare in your process.
It's a great point. I'm glad you guys have brought it up, because obviously, being the people that are in touch with the customer, and we're the ones that, we get the complaint is, hey, these are not toys, these are enterprise drones. We don't want a new one every year. We need a 5-year or a 10-year, whatever it is. So I get that all the time. And again, it's a function of the biggest players in this industry being much more interested in the consumer side than the enterprise side. Now, I think the enterprise side has grown enough to the point where people will start realizing its potential and will do exactly that. But I suspect possibly from our side there might be a single drone, and it just has a modular sensing system, right? And so the drone and the box are consistent, and you achieve what Edwin has talked about by just swapping in a payload kit at a certain weight, right? And you might have 3 size drones that can take a different weight. But we'll see. I mean, that's the fun part of what we're doing. So,
Kevin, do you see from your side customers needing that? Like, they want the longevity. Obviously, they want to buy a drone and it lasts 40 years. That's the ideal scenario, which there's realities in place there. But do you see that, like, when you're talking with different manufacturers, different platform providers, that's a conversation piece that comes up in the value proposition? Like, hey, how long are you going to actually have this in market? What's the end of life strategy? Or is it kind of like something that resellers are starting to learn now that they have to start asking?
It's a great question, and I think this is on the reseller market. Is, again, we're kind of in the same boat as the manufacturers, in that 95% of these resellers they were hobby shops, or they were selling consumer drones, right? So RMUS, I mean, I'm not saying we're perfect at it. We're far from that, but we've never been a consumer company, right? So we should know better. But it's a newer thing even for us, Josh, and it's critically important because, at the end of the day, they're used to a new one every year. But the customers are saying, we have to do this, particularly as our fleets scale, and we need to have a yearly maintenance budget, and we need to have all of this stuff budgeted 5 years out, where we know we might not have the latest technology in 3 years even. But we need 5-year life cycle based on how we're depreciating the equipment, or whatever our capital funding is going to be, right? So it's a great point.
Yeah, actually, we call it this at Votix, and when we talk to customers that are maturing their drone programs, we call it the second wave. Is when you go through the first wave is just kind of being amazed with whatever drone you bought. And you started, leveraging on that and seeing that there's benefits in that drone and growing into certain fleet, and suddenly realizing that you need process, you need, certain controls, certain governance. You start, changing aircraft, needing some other stuff, and the company has gradually realized that this is way much more complex and needs more governance. And perhaps there's a software behind it that can support, and certain processes that must be defined. Yeah, that's what we call the second wave.
Yeah, and we'll see, I think, a lot more interest in the software side. So we're getting close to time, so I got a couple of questions I'm just going to ask from the chat, really rapid fire. So Curt, we had a question in there, maintenance for the systems. What can you give us a quick summary of? Is there a lot of maintenance? What needs to be maintained on the systems outside of the aircraft?
Yeah, so with some of our systems that do exist in pretty tough environments, such as like above 100 degrees Fahrenheit, above 90 Fahrenheit, we do have a compressor-based cooling system, and similar to most HVACs currently in service, they should be checked on about every 6 months to a year. However, we do have internal indicators that report any kind of issue. And so our basically we've been growing our mean time before failure in any of these systems. And right now, the as we go towards full rollout, it's comes down to the maintenance cycle of an HVAC machine, which is 2 to 3 years, and we've got a whole structured plan for that that comes in all of our manuals. And so many of the just hardware and mechanics within the system are getting designed. We've got quite a few brains behind them now that when we go with full production rollout will be very low maintenance, and especially with many of the systems that only perform things like battery charging. It's a simple drawer in and out mechanism. And so we have maintenance schedules, of course, as we submit them to many of these regulatory providers. Typically, it would come down to the required maintenance schedule would be every 1 to 3 months, where you just open it up and take a look to ensure everything's good. And then after that, you follow a standard cycle every 3 months or so. And so all of this is mandated by different regulatory bodies in different countries. Some require more maintenance procedures than others.
Perfect. We had another question about the availability of avoidance, so DAA systems. So how really quick, how important are they? Is that something, have you guys worked at integrating Iris or some of the other options there?
Yeah, actually on our end, we fully support not only Curt's stations and everything that is on board, that station, but also Iris automation systems. And there's a couple of cases we actually support their towers and their meshes, but also the ones that are on board. So it's cool for airspace awareness while operating. And I think it's key, for certain critical operations, especially with the government.
Okay. And then the other question from Jennifer, what about 5G connectivity or LTE connectivity for control and data sharing, streaming?
So from my end, inside of the Nest, we do have capability to integrate cellular routers modularly. So as long as they've got something like an Ethernet output, you connect that internally, and you can put in a 5G router, a 4G LTE router. We've got some even using things like Starlink that just plug in and integrate directly. And I know from this end, we're able to receive relatively high bandwidths depending on the service provider and the capabilities of the router. That then we stream, or that streams through systems like Votix in order to command and control even from your own smartphone. Edwin had me one day fly the drone just from my smartphone in real time, and that was quite amazing. That's innovation. It was great.
Yep. Yeah, exactly. On our end, Kevin, we definitely rely. I mean, since we have telepiloting, telecontrol, and high definition streaming, relying on a good connectivity is important. So I think 5G is going to become very important to have a steady and reliable telecontrol capability and real-time streaming. However, we developed such a technology that even with the current connectivity that there's out there in 4G, we have less than a quarter of a second in latency for telecontrol and real-time streaming, and sometimes only for streaming even down to 49, 50 milliseconds, which is fantastic in high resolution. But it's also important to understand that we also support satellite connectivity, Wi-Fi, which is deployed in a mesh, to certain place, and some other mechanisms. Some other people has come with interesting ideas on connectivity. We are actually connectivity agnostic too.
Right, I love it. Okay, well, fantastic. So I want to thank our panelists, Josh, Curt, Edwin. You guys have been fantastic. Now, you guys are all going to come on the podcast with me individually, and we're gonna talk in depth about your things. So I'm looking forward to that. So for our listeners, hopefully we'll get those happening in January, February, March. So these guys are super busy, and I really appreciate them joining us. So we will, if you're watching it live, great. If you didn't catch this live, we will post this up in the usual places, so you'll be able to watch and share. And we look forward in continuing to move forward in this space in 2023. So thanks again. Everybody have a wondrous holiday season, and we'll see you in 2023.
Thank you, Kevin. Have a great day. Bye-bye, guys.
Bye.